By 2025, 263 million students will be ready to enter college. To accommodate this number, we need to build 15 universities per week for the next 15 years. If we aren't building those universities, competition to enter current ones is going to get tougher. Every mark is worth 10,000 positions in India's premier engineering exam, IIT JEE today. Picture the scenario with over 15 million new babies being added every year. How can it all change? Enter the revolution in education online.
Hi all, very happy morning to each and every viewer who is watching this video. Very happy morning. Lot of students from last few days are asking me to take a video on maxima and minimum value of quadratic expressions. Most of the students are probably not understanding the importance of the graphs to solve some of the maxima minima problems in quadratic expression. This session is purely based on the video on demand request from the student community to help them how to use the graphs to solve maxima and minima problems, especially related to quadratic expressions. Now, today in this class, to all the students who are watching this session, at the end of the session, you will understand how to find out the maxima and minima of a quadratic expression, how to draw the graph of a quadratic expression, how to see the behavior of the graph based upon a discriminant for a quadratic equation. If discriminant is greater than 0, how will be the graph? If discriminant is equivalent to 0, how will be the graph? If the discriminant is less than 0, what will be the graph? And some of the very good high level problems solved in seconds based upon these concept. Very interesting class, a class of close to about 1 hour, pure content based. Any student who is preparing for CAT 2020 examination, any student who is preparing for Staff Selection Commission examination, any student who is doing their schooling and finding it very difficult to understand quadratic expressions or quadratic equation related problems, any student who is a maths lover will definitely enjoy this class. Right? In case if you are enjoying the content, whatever I am discussing, kindly keep it in the comment box which video you want me to keep, so that definitely I will spend a lot of time in helping the students clear the competitive examination who could not afford the fees. Maxima and minima value quadratic expression. Let us start the class. Now, first we will see the introduction of quadratic equations. Now see here. Forget about maxima and minima. Now quadratic expression. Kindly sit in the class with a notebook and a pen. Make a note of every important key point. Now quadratic equation. A quadratic equation will have degree 2. Any equation with a degree 2 is called a quadratic equation. So degree 2, a polynomial expression which is of the form degree 2, the generic form will be ax square plus bx plus c. Ax square plus bx plus c. The highest degree for x is 2. So a cannot be equivalent to 0. If a is equivalent to 0, coefficient of x square becomes 0. Then it becomes a linear expression. A cannot be equivalent to 0. First point, it is clear. This is the generic form of the quadratic equation. Now, suppose for example, x square minus 7x plus 12. This is nothing but an expression with a degree 2. So this is a quadratic expression. X square plus 4x plus 4. This is also a quadratic expression. X square minus 4x plus 1. It is also a quadratic expression. All these three, if they are equated to 0, I will get a quadratic equation. If an expression is equated with something, then it is called an equation. Equation equated with something. Equation equated with something. Now why I took these 3 examples. Now if you see, the generic discriminant for a quadratic expression is equation is given by b square minus 4ac. B square minus 4ac. What does that discriminant will tell you? Discriminant will tell you about the behavior of the roots or the nature of the roots. Nature of the roots can be determined by using discriminant, that is b square minus 4ac. These b square minus 4ac, depending upon the question, if you substitute the values, d can be greater than 0, d can be equivalent to 0, d can be less than 0. D can be less than 0. Any value if you substitute on a number line, either it can be equivalent to 0 or it can be greater than 0 or it can be less than 0. D equivalent to 0. Roots are real and equal. Roots are real and equal. Roots are real and equal. D less than 0. Roots are imaginary. Roots are imaginary. Imaginary roots are the roots which you cannot draw it on a number line. Discriminant greater than 0. Real and unequal. Real and unequal. D greater than 0, D equivalent to 0. That will give you real roots. Discriminant less than 0, that will give you imaginary roots. What is the difference between a real root and an imaginary root? Real roots are the roots which you can draw it on a number line. Draw it on a number line. Imaginary roots you cannot draw it on a number line. So what does that mean? A root is a value which will touch the x-axis. Now I'll come to the point in the next slide. Now see here. Roots are the values which will touch the x-axis. Very important slide. So in this slide we have seen the generic form of the quadratic expression. Write some 3 examples. These is nothing but discriminant greater than 0. These is nothing but discriminant equivalent to 0. These is nothing but if you see 16 minus 4, D is greater than 0. I hope the idea it is clear. Right? Now we will see all the possible examples. Step by step, slide by slide, concept by concept, problem by problem, application by application. I will take you from a basic level to an advanced level. D greater than 0. Now here I wrote one important point, root. Now let us see the root, the difference between a root and an x. Solution. Now if you see, suppose if I take an example, f of x is x square minus 5x plus 6. This is nothing but a quadratic expression. If a quadratic expression is equated with 0, I will get quadratic equation. F of x is equivalent to 0. That means x square minus 5x plus 6 equivalent to 0. This is nothing but x minus 2 into x minus 3 equivalent to 0. X minus 2 into x minus 3 equivalent to 0. Now if you observe, product of two linear expressions, it is equivalent to 0. Either this should be equivalent to 0 or this should be equivalent to 0. 0 into something 0. So x minus 2, if it is 0, x is 2. X is 2. So at x equivalent to 2, f of 2, if I substitute this, I am getting 2 square minus 5 into 2 plus 6. 4 plus 6 is 10, 10 minus 10 0. At x equivalent to 2, f of x is equivalent to 0. Similarly, x minus 3 is equivalent to 0, x equivalent to 3. At f of 3, this is nothing but 3 square minus 5 into 3 plus 6. 9 plus 6, 15. 15 minus 15 equivalent to 0. That means at some value of x, if the quadratic expression is f of ax square plus bx plus c, if I substitute that x value, I am getting right hand side 0. Then that value of x is called the root. What is the value of x at which the expression will become 0? That value of x is termed as root. A root is the value x takes such that the expression becomes 0. I hope the point is clear. So here 2, 3 are the roots of the quadratic equation because it is equated with 0. It is equated with 0. One very important observation. I am telling you that y value will be 0. I am telling you that y value will be 0 in a coordinate geometry. In a coordinate geometry, where will be the point where y value will be 0? Y value will be 0 will be the point on the x-axis. If x value is 0, then that will be the point on the y-axis. So if I take a point on x-axis, y value will be 0. Y value will be 0. Here I got y value will be a 0. Or in simple language, a root touches the x-axis. A root is the value of x that touches the x-axis. Please write down in your notes. A root is nothing but the value of x that will touch the x-axis. That will touch the x-axis. If I say something is a root, it has to touch the x-axis. If I say something is a root, it has to touch the x-axis. Now, with this, another important difference between root and solution. Root and solution we will discuss. Root and solution we will discuss. Listen carefully. Suppose there is a graph like this. There is a graph like this. Let me take another graph. This is the graph drawn for a particular expression. This is the graph. Now if you see, two graphs are intersecting at, this is the first point. Two graphs are intersecting at, this is the second point. Two graphs are intersecting at, this is the third point. Two graphs are intersecting at, this is the fourth point. That means there are 4 points of intersection of two curves. I hope it is clear. There are 4 points of intersection of two curves. These two curves are intersecting at 4 points. The point of intersection of two curves is called the solution. The point of intersection of two curves is called the solution. But out of these 4 solutions, there are only 2 solutions where y value will be, 3 solutions, not 2. These 1 point, these 1 point, these 1 point. That means there are 4 solutions for these 2 curves. Out of these 4 solutions, there are 3 solutions. There are 3 solutions where y value will be 0. There are 3 solutions where y value will be 0. If y value will be 0, what will be the term for that particular y value of x? That is called the root. That is called the root. That is called the root. I hope it is clear. A root is nothing but a solution which makes y value 0. Please write down in your notebook. A root is nothing but a solution. Right? A root is a solution which makes y value 0. A root is a solution which makes y value 0. You take all the point of intersection of two curves, the point of intersection of two curves where y value will be 0, it is called the root. I hope you understood the definition of a root, you understood the definition of a solution, and you understood the difference between a root and a solution. I hope this slide is clear. Do not get confused between root and a solution. Root and a solution. A solution is nothing but a point of intersection of two curves. A root is nothing but a solution which makes y value equivalent to 0. Which makes y value equivalent to 0. This idea, it is clear. Root and solution. Now let us see some more important concepts. Once you are good in concepts, then solving a problem will be very, very easy. Now if I take quadratic equation. Now in the quadratic equation, one by one we will discuss. Quadratic equation. Key point number 1. Key point number 1. In key point number 1, now the quadratic expression, the generic form will be ax square plus bx plus c. This is the generic form of the quadratic expression. A cannot be equivalent to 0. If A cannot be equivalent to 0, there are two cases. Either A can be greater than 0 or A can be less than 0. Key point 1. A is greater than 0. A is greater than 0. Case 1. Case 1. If I take three cases, I will take discriminant greater than 0. Case number 2. Discriminant equivalent to 0. Discriminant equivalent to 0. Case number 3. Discriminant less than 0. So we discussed that, right? There are three cases at which the roots will be there. Two cases will have real roots. Real roots are the roots which can be drawn on a number line. Imaginary roots which you cannot draw it on a number line. So three cases under the concept A greater than 0. Under the concept A greater than 0. Discriminant greater than 0. Discriminant equivalent to 0. Discriminant less than 0. Example. X square minus 5x plus 6. Discriminant will be b square minus 4ac. b square minus 4ac will be b square minus 5 square minus 4 into 1 into 6. 25 minus 24, 1 greater than 0. Discriminant greater than 0. If this expression is equated with 0, if I equate with 0, the value of x that will make this expression y value 0, they are called the roots. 2 and 3 are the roots. These are the roots which will, root is a value which will touch the axis. Take an x-axis and take a y-axis. Suppose at x equivalent to 2, y value will be 0. At x equivalent to 3, y value will be 0. Now let me see the graph. Suppose if I take 2 and 3. 2 and 3. Let me see the graph at x equivalent to 4. 4 is nothing but 4 square minus 5 into 4 plus 6. This is nothing but 16 plus 6, 22. 22 minus 20, 20 at x. So this will be the graph. Similarly, if I take x equivalent to 1, 1 square minus 5 into 1 plus 6. 1 plus 6, 7, 7 minus 5, 2. Again the graph will be like this. Again the graph will be like this. So that means the graph is, suppose these like this, it is clearly shown. Let us take x equivalent to 2.5. 2.5 square minus 5 into 2.5 plus 6. 2.5 is 6.5. 6.25. 6.25 plus 6, which is nothing but 12.25. 5 into 2.5 is 12.5. 12.25 minus 12.5 is negative. That means you are getting negative. So it is clearly shown that the graph is going upwards. I hope you are all there with me. How did I plot the graph? I plotted the graph by first taking the roots of x at x equivalent to 2, y equivalent to 0, at x equivalent to 3, y equivalent to 0. 2 points I have taken. Then I have taken a value x greater than 3. The value came out to be positive. Then I took a value x less than 2. I got a positive value. I took x equivalent to 2.5. The value came out to be negative. So positive, x positive, y negative. So the graph will be like this. The graph will be, I will just draw it with a different color. This is the graph for a greater than 0 and discriminant greater than 0. I hope the idea it is clear. Discriminant equivalent to 0. Suppose if I take x square minus 4x plus 4. This is a quadratic expression. Discriminant is b square minus 4ac. Discriminant is b square minus 4ac. This is nothing but minus 4 square minus 4 into 1 into 4. 16 minus 16, it is nothing but 0. Discriminant equivalent to 0. If discriminant equivalent to 0, roots are real and equal. Roots are real and equal. Let us see the behavior of the graph. So these are nothing but x minus 2 whole square. So x minus 2 equivalent to 0. 1 is x equivalent to 2. This is the root. Let me see the behavior of the graph. At x equivalent to 0, 0 minus 0 plus 4, 4 positive. So if x equivalent to 3, 3 square 9, minus 4 into 3, minus 12, 9 plus 4, 13, minus 12, 1. This is the graph. This is the graph. That means the graph is just going upwards when compared to the previous things. So these one graph where the graph is touching the axis at 2 points. This is the graph where the graph is touching the axis at only 1 point. If you observe, similarly, if I take an example of x square minus 4x plus 13, discriminant is less than 0. B square minus 4ac. I hope the idea it is clear. 16 minus 52, it is less than 0. So if the discriminant is less than 0, then the roots are imaginary roots. Can the imaginary roots, can it be drawn on a number line? No, it cannot touch the x-axis. If you see 1 is a little down, then it is touching the axis, then it will go above. Then it will go above. These are the three cases under the graph ax square plus bx plus c when a is greater than 0. We discussed that a quadratic expression a cannot be equivalent to 0. If a cannot be equivalent to 0, three cases will come: a greater than, d greater than 0, d equivalent to 0, and d less than 0. Discriminant equivalent to 0, the graph will touch the axis at 1 point. D greater than 0, the graph will touch the axis at 2 points. D less than 0, the graph will not touch the axis. Extremely important key point. Now, let me write down again. So, these are nothing but, if you see here, a greater than 0, a greater than 0, case 1. Discriminant greater than 0, the graph is touching the axis at 2 points. Another important observation, the graph is going upwards. These are nothing but the minimum value. That means y minimum I can determine. Y minimum I can determine. Y maximum it is shooting up to infinite. So these are nothing but plus infinite. I will tell you why it is minus b by 2a and minus d by 4a. Right? These x value will be minus b by 2a and this will be minus d by 4a. X minimum will be, I will also prove it to you, why x minimum is minus b by 2a minus d by 4a. Case 1, a equivalent to 0. A greater than 0, a greater than 0, case number 2, discriminant equivalent to 0, the graph will touch the axis at only 1 point. That means alpha and beta both will be equal and it is equivalent to minus b by 2a and it is equivalent to minus b by 2a. X minimum and the roots both will coincide only at discriminant equivalent to 0. X minimum and alpha and beta both will coincide only when a is equivalent to 0. Case number 3. Discriminant less than 0. Discriminant less than 0. The roots are imaginary. So the graph will go upwards. What is important to me in case number 3 is, in a Cartesian plane, x is positive, y is positive. X is negative, y is positive. X is negative, y is negative. X is positive, y is negative. If you observe these graph, the graph is entirely lying on the x-axis. The graph can shift from right to left. It can probably be like this, it can also be like this, but really it does not matter because in first and second quadrant y value is always positive. Case number 3 is a very important key point. Case number 3 is telling us y is always greater than 0. Y is always greater than 0. What is y? Y is ax square plus bx plus c. That means a quadratic expression ax square plus bx plus c, it is always greater than 0. When it will be greater than 0? Only if a is greater than 0 and d is less than 0. Only when the coefficient of x square is greater than 0 and the discriminant is less than 0, then the quadratic expression ax square plus bx plus c, that will be greater than 0. I hope the idea it is clear. Again, I am writing this idea. Extremely important idea, sir. Why? Y is nothing but a quadratic expression ax square plus bx plus c. For it to be greater than 0, only if a is greater than 0 and discriminant is less than 0, and it is discriminant is less than 0. Extremely important key point, sir. If you know this key point, you can solve a lot of problems very easily. Ax square plus bx plus c, ax square plus bx plus c, only if a greater than 0 and d less than 0. Suppose, for example, it is greater than 0. Now 6x square minus 18x minus 18x, for example, plus 17. Options are, is it greater than 0? Is it equivalent to 0? Is it less than 0? Is it less than 0? There is a quadratic expression that is given to you, right? Now he is asking what will be the nature of this quadratic expression, whether it will be greater than 0, equivalent to 0 and less than 0. So we have seen, first we will see quadratic expression a is 6, which is greater than 0. Discriminant, which is b square minus 4ac. These are nothing but minus 18 square minus 4 into 6 into 17. These are nothing but 324 minus 6 17s are 102 minus 408. Discriminant is less than 0. A greater than 0, d less than 0. A greater, if this is true, this will also be true. If this is true, this will also be true. I hope the idea it is clear. A greater than 0, d less than 0. So what will be the expression? Inequality, it will be greater than 0. You can find out the nature of a quadratic expression, whether it is greater than 0, whether it is less than 0, or whether it is equivalent to 0 by knowing the graph of the quadratic expression. I hope the idea it is clear. A graph of a quadratic expression, if you are able to plot it, you can do a lot of things. You can tell when alpha and beta and minus b by 2a, it will be equal at d equivalent to 0, right? When the graph will touch the axis at 2 points, when d is greater than 0, when d is less than 0 and a is greater than 0, the complete quadratic expression inequality will be greater than 0. I hope the idea is clear. Suppose, for example, another question is there. X square minus kx plus 9, this is greater than 0. X square minus kx plus 9, it is greater than 0. For it to satisfy this inequality, what should be the range of k that should satisfy this quadratic inequality? Good question, a logical question, a conceptual question. X square minus kx plus 9 greater than 0. What should be the range of k? This entire quadratic expression, it is greater than 0. If it is greater than 0, a will be greater than 0. 1 is greater than 0. Discriminant should be less than 0. Discriminant is nothing but b square minus 4ac. 4 into 9 less than 0. This is k square minus 36 less than 0. These are nothing but k square minus 6 square less than 0. A square minus b square. A minus b into a plus b less than 0. If there is a less than inequality, the value of k always lies between the lowest critical point and the highest critical point. Answer is minus 6 less than k less than 6. minus 6 less than k less than 6. It's very easy. What you do is you take k equivalent to 0, 0 minus 6 minus 6, 0 plus 6 plus 6, minus 36 is less than 0. So that take some ranges of k and check it out. If I take k equivalent to 7, just check it out. 7 minus 6 is positive. 7 plus 6 is positive. Positive into positive. It cannot be less than 0. Take a value less than minus 6. Minus 7. Minus 7 minus 6 minus 13. Minus 7 minus 6. Right? Minus 1. Minus into minus is plus. But the expression should be less than 0. This is one way of asking a question. He will also ask you what should be the range of a particular variable if a quadratic expression is greater than 0. I hope the idea it is clear. This concept it is clear, right? So what we did, case number 1. Case number 1. Now if you see here, another key point, x square minus 5x plus 6, x square minus 5x plus 6, these nothing but x minus 2 and x minus 3. I hope it is clear. Suppose if I equate it with 0, x is nothing but 2 comma 3. So the critical points of x are 2 and 3. We have seen the graph is like this, 2 and 3, 2 and 3. These minimum value is nothing but the mean of the critical points. That means these, if I take these as alpha, these nothing but beta, and it is touching the axis at 2 points. These x minimum is nothing but alpha plus beta by 2. Alpha plus beta by 2. I hope it is clear. It is very easy to prove. Ax square plus bx plus c. Sum of the roots. It is nothing but minus b by a. If I divide it by 2, alpha plus beta by 2, it is nothing but minus b by 2a. I told you that x minimum value is minus b by 2a. Then substituting the value, I will get minus d by 4a. These even you don't need to mug it up. So what will be the x minimum for this value? You don't need to mug up. It is nothing but the alpha plus beta by 2. 2 plus 3 by 2. 5 by 2. 5 by 2 is nothing but 2.5. X minimum, it is nothing but 2.5. If I want y minimum, wherever x is there, if I substitute x minimum, I will get y minimum. So these are nothing but 2.5 whole square minus 5 into 2.5 plus 6. This is the answer. This is the y minimum. I hope the idea it is clear. When it is touching the axis at 2 points, x minimum will be alpha plus beta by 2. These are nothing but alpha plus beta by 2. I hope the idea it is clear. Suppose if anybody is asking you a question, y is nothing but x minus 4 into x minus 8. Y minimum he is asking and x minimum he is asking. Y minimum and x minimum. These are nothing but 2 roots. So x minimum is nothing but alpha plus beta by 2. 4 plus 8 by 2. 12 by 2, it is nothing but 6. X minimum, it is nothing but 6. Y minimum will be 6 minus 4 into 6 minus 8. These are nothing but 2 into minus 2. Answer is nothing but minus 4. Answer is nothing but minus 4. I hope the idea it is clear. Answer is nothing but minus 4. Sir, Anil sir, these touching the axis at 2 points. These touching the axis at 2 points. Now, if it is like this, y is x minus 2 into x minus 2. You don't need to do it because the graph will touch the x-axis at exactly 1 point. That too on x-axis, this will be 0. And alpha and beta both are equal and it is equivalent to minus b by 2a. So answer is nothing but x minimum will be 2, y minimum will be 0. I hope it is clear. We will focus on, we have seen a greater than 0, d less than 0. A greater than 0, d equivalent to 0. A greater than 0, d equivalent to 0 we did it, d greater than 0 we did it, now d less than 0 also we did it. I hope the idea it is clear. Kindly watch this class again, make a note of every important key point, then you will understand it very very clearly. We have seen the graph of a greater than 0. Now key point number 2. Key point number 2. Key point 2, it is nothing but a is less than 0. A is less than 0. If a is less than 0, suppose see here, in case 1, a greater than 0, d greater than 0, this is the graph we got. This is the graph we got. Similarly, here, if I take a less than 0, a less than 0, and d greater than 0, just the graph will be ulta pulta, sir. Right? The graph will be nothing but the graph is like this. The graph is like this. The graph is nothing but a reflection along x-axis. The graph is nothing but a reflection along x-axis. I hope the idea it is clear. The graph is nothing but a reflection along x-axis. Why it is happening? Reflection along x-axis. Now see here. These is nothing but x square minus 5x plus 6. These is y. Listen carefully, sir. These is nothing but minus x square plus 5x minus 6. If I take y minus common, these is nothing but x square minus 5x plus 6. X square minus 5x plus 6. These is nothing but entire value is y. Y is becoming minus y. Yes or no? Y is becoming minus y. Y is becoming minus y. That is nothing but reflection along x-axis. Please make a note. If I say reflection along x-axis, reflection along x-axis, this is also called as the water image. A water wave will be like this. This is nothing but a water image. Water image is nothing but the reflection along x-axis. In reflection along x-axis, what is that we will do? We will do y with minus y replacement. Please make a note. Reflection along x-axis. Reflection along x-axis. It is nothing but water image, and in a water image we will replace y with minus y. If this is a water, right, water image will be nothing but the mirror image. This will be the graph. I hope the idea it is clear. Now let us write down one important key point. All these key points are extremely important, sir. One is mirror image, another is water image. Mirror image, a good number of questions are based on mirror image and a water image. Mirror image, water image, and we will also see mirror plus water image. Mirror plus water image. Now see here. In water image, what is that we did it? Water will be like this. These are nothing but an x-axis. So these are nothing but a reflection along x-axis. These are nothing but reflection along x-axis. Reflection along x-axis. What is that we did? We did replacing y with minus y. We are replacing y with minus y. I hope mirror water image concept is clear to you. Mirror image, mirror will be like this. So these are nothing but a reflection along y-axis. These are nothing but reflection along y-axis. Reflection along y-axis. Reflection along y-axis. If it is a reflection along y-axis, these are nothing but replace x with minus x. Replace x with minus x. If I replace x with minus x, I will get a mirror image. Mirror image is nothing but the reflection along y-axis. Mirror plus water image. Mirror plus water image. Now, if you see here, water image, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. First quadrant, fourth quadrant, this is nothing but a water image. Are you all with me? Right? Second quadrant, third quadrant, These is nothing but a water image. So in a water image, first quadrant graph will become fourth quadrant graph. Fourth quadrant graph will become the first quadrant graph. Mirror image, these is nothing but the mirror. First quadrant graph will become the second quadrant graph. These is also the mirror. Third quadrant graph will become the fourth quadrant graph. Fourth quadrant graph. Mirror plus water image. That means first I will do mirror, then I will do water. That means these is nothing but the first quadrant graph will become the third quadrant, and the second quadrant graph will become the fourth quadrant graph. I hope the idea it is clear. First quadrant graph will become the third quadrant, and second quadrant graph will become the fourth quadrant graph. These are nothing but the reflection along origin. These are nothing but reflection along origin. Very, very important points. Reflection along origin. Mirror plus water image or water plus mirror image, both will be the same thing. These are nothing but the reflection along origin. First I am doing y with minus y, x with minus x, or x with minus x or y with minus y. Here what we will do is I will replace x comma y. I will replace x comma y with minus x comma minus y. I will replace x comma y with minus x comma minus y. I hope the idea it is clear. One is a mirror image. Mirror will be like this. So definitely there is no confusion. It is a reflection along y-axis. Water bed will be like this. It is a reflection along x-axis. Mirror is a reflection along y-axis. In a y-axis, replace x with minus x. In a water image, replace water image is x-axis, so replace y with minus y. Mirror plus water image, replace x comma y with minus x comma minus y. I hope the idea it is clear. The definition of a mirror image, definition of a water image, and a definition of a mirror and a water image. Again I will come to this point when I am solving modulus function. Idea it is clear, right? Mirror image, water image, and mirror plus water image. Now let us use this concept to see the graph for key point number 2. Each and every concept explained in detail, explained in a detail, right? A is less than 0. If A is less than 0, case number 1, discriminant greater than 0. Case number 2, discriminant equivalent to 0. Case number 3, discriminant less than 0. A less than 0, the graph will be reflection along x-axis. So the graph 1 is upwards, so now it will become downwards. So only these reflection along x-axis. These nothing but like this, and these nothing but like this. I hope the idea it is clear. Rest all concepts remains the same. At discriminant greater than 0, the graph will touch the axis at 2 points. It will touch the axis at 1 point. It will not touch the axis. These x positive, y positive, x negative, y positive, x negative, y negative, x positive, y negative. So the graph is completely going towards the fourth quadrant. It can also shift to the third quadrant, but y is always negative. Another important key point. X square plus bx plus c. This is the graph. Y less than 0. Y is ax square plus bx plus c. Ax square plus bx plus c. It is always less than 0 only if a is less than 0 and d is less than 0. Only if a is less than 0 and d is less than 0. Very, very important key point. There is no confusion. A quadratic expression will be greater than 0 only when a is greater than 0. Discriminant less than 0 is common. Discriminant less than 0, the graph will not touch the axis. Discriminant less than 0 is common. Expression will be greater than 0 when a greater than 0. Expression will be less than 0 when a is less than 0. I hope the idea it is clear. I hope the idea it is clear. For For example, if I take an example of minus 5x square plus 7x plus 7x plus 7x plus, if I see here, minus 2, let us take instead of plus, no, not even minus 2, that will result in an easy equation, minus 8, minus 5x square plus 7x minus 8. What is this quadratic expression? Is it greater than 0? Is it equivalent to 0? Is it less than 0? Is it less than 0? Now see here, minus 5x square plus 7x minus 8. A is minus 5, which is less than 0. Discriminant is b square minus 4ac. 7 square minus 4 into minus 5 into minus 8. These 49. Minus 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 160. It is minus 111. Less than 0. A less than 0, D less than 0. So what will be the quadratic expression? Quadratic expression will be less than 0. I hope this example is clear. Ax square plus bx plus c. This inequality will be less than 0 when a less than 0 and d less than 0. I hope the idea it is clear. So the important key points will write. Ax square plus bx plus c. These ax square plus bx plus c, these entire expression will be ax square plus bx plus c. It is greater than 0 only if a is greater than 0 and d is less than 0. And this expression ax square plus bx plus c, it is less than 0 only if a is less than 0 and d is less than 0. Please remember, the quadratic inequality greater than 0 or less than 0 is solely dependent on a greater than 0 or a less than 0. Anyway, discriminant should be less than 0. Discriminant less than 0, the graph will go either upwards or downwards. It will go upwards when a is greater than 0. When a is greater than 0, ax square plus bx plus c is greater than 0. When a is less than 0, ax square plus bx plus c, it is less than 0. Is the idea clear? Quadratic expression and the behavior of the quadratic expression when it is greater than 0 and when it is less than 0. Clear? Fundamentals clear? What all we discussed? Quadratic expression, discriminant of a quadratic expression, right? Definition of a root, difference between a root and a solution, graph of a quadratic expression when a greater than 0, d greater than 0, d equivalent to 0, d less than 0, ax square plus bx plus c when a less than 0, d greater than 0, d equivalent to 0 and d less than 0. I hope the idea it is clear. Now see here. Let us solve one by one this question. Find the maxima and the minimum value for the quadratic expressions. First question. Y is x square plus 10x plus 29. 10x plus 29. So if you see here, a is 1 greater than 0. A is 1 greater than 0. First we will see the behavior of the graph. Then we will come to know whether it is maxima or minima. Y will be b square minus 4ac. 10 square minus 4 into 1 into 29. 100 minus 116. So y is d. It is d, not y. Discriminant is less than 0. The graph is going upwards. The graph is going upwards. If the graph is going upwards, definitely we can determine minimum. Maximum will be the graph is going upwards, so it is plus infinite. This is the behavior of the graph. This is the behavior of the graph. Now we have to find out. Now this is nothing but, can I write? It is nothing but x plus 5 whole square plus 4. Yes or no? X plus 5 whole square plus 4. X plus 5 whole square plus 4. Now if you observe carefully, D is nothing but a square function. Square function is always greater than or equivalent to 0. At x equivalent to minus 5, this will be 0. So, D is always greater than or equivalent to 0 plus 4. That means y minimum value will be 4. When it will be 4? When this expression is equated with 0. So, D is nothing but at x equivalent to minus 5. At x equivalent to minus 5 plus 5, it is nothing but 0. 0 square is 0. 0 plus 4, 4. Y minimum will be 4. Y minimum will be 4 at x minimum minus 5. I hope the idea is clear. You don't need to use any formula based learning to solve this question. Just by looking at a question, you will understand the behavior of the graph. Y minimum, it is nothing but 4 at x minimum minus 5. At x minimum minus 5. So y minimum, it is nothing but 4. At x minimum, it is minus 5. I hope the idea, it is clear. So what we did, first we saw the coefficient of x square, which is greater than 0. Then we have seen the discriminant. It is less than 0. A greater than 0 and D less than 0. The graph is going upwards. So maximum will be plus infinite. Minimum will be 4 plus positive value. So the value will keep on growing after 4. Y minimum will be 4 at x minimum minus 5. First question, basic understanding. I hope the idea, it is clear. Second one, it is nothing but 2x square plus 5x plus 7. A is nothing but 2, which is nothing but greater than 0. Discriminant is nothing but b square minus 4ac. 5 square minus 4 into 2 into 7. So 25 minus 8 sevens are 56. Which is nothing but D is minus 31 less than 0. That means the graph is going upwards. The graph is going upwards. Maximum, y maximum will be plus infinite. Y minimum will be a point at x minimum equivalent to something. That also we will see. 2x square plus 5x plus 7. Now we have already seen x minimum, it is nothing but minus b by 2a. And y minimum, it is nothing but minus d by 4a. If you are able to determine the roots. Otherwise use this notation. So these is nothing but minus 5 by 2 into 2. This is nothing but 4. Minus 5 by 4. Minus d by 4a. Minus d is minus 31 divided by 4 into 2. So y minimum is nothing but 31 by 8. At what value? At x minimum, which is nothing but minus b by 2a. I hope it is clear. So what is this one? This is nothing but minus b by 2a. I already told you that it is nothing but alpha plus beta by 2. Alpha plus beta, it is nothing but the sum of the roots. Sum of the roots is minus 5 by 2 by 2, which is nothing but minus 5 by 4. Once you determine alpha plus beta by 2, just either you substitute or you use minus d by 4a. Because we got d already, I am using it. I hope the idea, it is clear. Next, third question. Right? Third question. The second also we solved it. Third one. Now, these not like a quadratic expression. How to solve? So, best way to solve is, let take x cube equivalent to a. So, these nothing but a into a plus 1 into a plus 2 into a plus 3. Take first and fourth and second and third. These are nothing but a square plus 3a into a square plus 3a plus 2. A square plus 3a plus 2. These are nothing but a square plus 3a. It is nothing but p. These are nothing but p plus 2. P into p plus 2. These are nothing but p square plus 2p. Add 1 and subtract 1. These is nothing but p square plus 2p plus 1 minus 1. These is nothing but minus 1 plus p plus 1 whole square. Minus 1 plus p plus 1 whole square. Again it is nothing but a square function. Square function will be greater than 0. So what is the y minimum for this one? Y minimum, it is nothing but minus 1. Y minimum, it is nothing but minus 1. P square plus 2p minus 1 plus p plus 1 whole square. The value is growing right after minus 1. So y maximum will be plus infinite. Very, very good question. I hope you understood the idea how to solve this question. Let x cube equivalent to a. Convert these polynomial expression into a quadratic expression. X cube equivalent to a. A into a plus 1 into a plus 2 into a plus 3. A square plus 3a. A square plus 3a plus 2. P into p plus 2. P square plus 2p, add 1 and subtract 1, minus 1 plus p plus 1 whole square. This is a square value. Square value will be greater than or equivalent to 0. When it will be equivalent to 0, when p equivalent to minus 1. Substitute it, you will get the x minimum value. Understood? Various varieties of question, we are going to solve it. This is problem number 3. Problem number 4, similar model. What you do is, these a. This will become a plus 3. This will become a plus 1. This will become a plus 2. A plus 2. A into a plus 1 into a plus 2 into a plus 3. Take first and fourth. These a into a plus 3. Second and third. A square plus 3a plus 2. So these are nothing but a square plus 3a into a square plus 3a plus 2. A square plus 3a into a square plus 3a plus 2. Now if I call these as, now next process, it is p and it is p plus 2. I hope the idea it is clear. So these are nothing but p square, same answer we are getting, p square plus 2p, add 1 and subtract 1. These minus 1 plus p plus 1 whole square. Y minimum, it is nothing but minus 1. Y minimum, it is nothing but minus 1. At what value? At p plus 1 equivalent to 0. At p plus 1 equivalent to 0, y minimum will be minus 1. I hope the idea it is clear. Let these value will be a. These is nothing but a plus 3. These is nothing but a plus 1 or a plus 2. Or after multiplying both of them, x plus 1, x plus 4, x square plus 5x plus 4. You can take x square plus 5x plus 4 as k. That also will give you answer. Idea it is clear, right? Y minimum, it is minus 1 at p plus 1 equivalent to 0. So at p equivalent to minus 1. I hope this idea it is clear. Next one. Another question where a is less than 0. So a is nothing but minus 1, it is less than 0. Discriminant, it is nothing but b square minus 4ac. 4 into 8 into minus 1. These are nothing but 16. If you see 16 plus minus into 16 plus 32. 16 plus 32. These are nothing but 48. Let us see by writing it how much we are getting it. These is nothing but 8 minus of x square plus 4x. X square plus 4x. Now if you see here, these is nothing but 8 minus of adding 4 and subtracting 4. Whenever you are confusion, you go by this method. These is nothing but 12 minus of x plus 2. 12 minus of, these is nothing but x plus 2 whole square. Are you all with me? 12 minus of x plus 2 whole square. X plus 2 whole square. Now 1 minute, sir. These also, now these also we will do it. Just 1 minute. We will write like this and we will do it so that there is no confusion. These is nothing but minus x square minus 4x plus 8. A is nothing but minus 1 less than 0. Discriminant is b square minus 4ac. So these is nothing but minus 4 square minus 4 into minus 1 into 8. So these is nothing but 16 plus 32. Discriminant, it is greater than 0. D greater than 0, A less than 0. So the graph will be down. I hope it is clear. The graph will be down. Now what is the max? 12, D is nothing but a square value. Square is always greater than 0. 12 minus something, the value will decrease. Y maximum? Y maximum will be 12. Y maximum will be 12. When it will be 12? At x maximum, at x plus 2 equivalent to 0. These nothing but minus 2. I hope the idea it is clear. Previous example, the graph is going upwards. In this example, the graph is coming downwards. Y maximum is 12, at x maximum equivalent to minus 2. I hope the idea it is clear, right? Very, very good question to explain the concept of the behavior of the graph, whether it is going upwards or whether it is coming downwards. Next one, same question. Now, if you see here, minus 7x square. A is nothing but minus 7. Minus 7, it is nothing but less than 0. Discriminant is b square minus 4ac. 4 into minus 7 into 5. These are nothing but 4 plus 28 5s are 140. Discriminant greater than 0. That means the graph will be like this. The graph will be like this. Minimum we cannot determine. So y minimum is, the graph is going downwards, minus infinite. So y maximum we can determine. When we can determine? At x maximum. What is x maximum? X maximum is minus b by 2a, which is nothing but alpha plus beta by 2. Alpha plus beta by 2. Sum of the roots is nothing but minus 2 by 7. Minus 2 by 7. These are nothing but the sum, minus 2 by minus 7. Minus 2 by minus 7 by 2. 2 cancel. These are nothing but minus of minus 1 by 7, which is 1 by 7. I hope the idea it is clear. Answer is x maximum will be 1 by 7. Y maximum will be nothing but minus d by 4a. Minus d by 4a. Minus 144 by 4 into a is nothing but minus 7. I hope the idea it is clear. How to find out the maxima and minima of a quadratic expression. How to find the maxima and minima of a quadratic expression. Still there are a lot of problems. There are about good number of problems. We will continue in the next session. I hope the introductory session it is very, very clear to you. In case if you are enjoying these conceptual way of learning, kindly like the video, and you are preparing for some examination where you wanted to learn only from the teachers who wrote the books. You can always WhatsApp this number 80500-67891. We are going to start CAT 2021. CAT 2021 course, right, where you will get access to 750 plus hours of video content and 800 plus tests and 650 plus ebooks. 750 plus hours of content. In case if you are preparing for any of the examinations for SSC or a bank or a placements 2021 cycle, you can always WhatsApp this number to know more about the details. In case if you enjoy the video, kindly comment on what you enjoyed it, and if you want me to take a particular topic, kindly mention it in the comment which topic you want me to take. Thanks a lot for watching the video. Keep subscribing to Anil Nair's YouTube channel to get a lot of scintillating content. Thank you. With love, Anil Nair.